So we've got that sim completed. Let me just zoom out and we can skip forward a few frames just to make sure that it's generally working. There we go. So you can see we've got bendy bits of metal and stuff, and it's kind of following along the general movement of the simulation of the previous simulation, right? Which is great. So now we need to apply this this simulation to the original geometry, right up here. So I'm also going to actually also poly reduce this, but just not to the same extent. Okay, I'm going to drop this down to 50%. You notice I can do that without getting those weird triangle-y things, and we still, we get all the detail that we need. We're not going to be, unless we got a camera like, like this on the building, we're going to be fine. So, and then we need to divide this. So we need this to be able to bend these bits of metal, right? So it's kind of strange. We are, removing geometry and then adding it again. But just to be sure that we've got enough to allow the polygons to bend, right? We need to use this Bricker polygon. I'm going to set this to 0.5 and turn off the convex polygons. Okay. Oh yeah, and then cache this. So drop a file cache, current frame, and then easier just to do it like this. This is, let's say, we'll call it metal frac subbed, since it's kind of subdivided, right? Load from disk, save to disk as well. Okay, so we need that down here. We can just stretch it down like that. Okay. And then what we use is a point deform. So we need the rest point lattice, so that's this, without moving. So we need a time shift on that. And then, let's go back to the first frame. Delete channels, so that's our rest, basically the first frame. Okay, and then we need, this will be the deformed, so that's the actual animation, and then this into this port. So let's view that. So we're deforming this with this and this, right? So this is we use the first frame to calculate the difference between the two and then apply that to this geometry. So now I don't think it will work. If it does, it will be not great. So what we need to do is tell it to only deform, to match each piece in the simulation to the subdivided pieces, right? And we can use that class attribute. It should come up there. Let's try just typing it in. Still no. Let's just double check that we've got it here. If not, we might need to just unpack this. Not there. Let's, oh, is it on the primitives? No. Let's, excuse me, unpack this. Okay, and then we've got that class attribute there. Okay, see if that works now. Still no. Maybe we need it on the point. So let's attribute promote. Let's just double check that we've got it on both sides. So we need the same class attribute on both sides here. Just make sure it's here. So we got it there as well, but just on the primitive. So let's attribute promote here. So primitive to point and class, and then the same over here. Okay, and then fingers crossed that works. Seems to be taking longer now, which is, yeah, there we go. Perfect. So And now each piece, so if we visualize the class attribute, so each piece is guided or deformed by its corresponding simulation piece, right? So we've got a few values here that we can play around with to try and improve this. You know, the radius of the, you know, how much control it has. If we raise that up, should smooth it out a bit. Yeah, it's a bit better. And maybe let's push this minimum points up as well. There we go. That's quite a bit better. So yeah, you can see it does take a while, so it's probably worth caching this out again. Yeah, so well, maybe we'll take care of that when we look at rendering this. But that's pretty much it for the metal. Okay, you know, to get better results, I would further divide this, but you know, we've already got a million, almost 2 million polygons there, or primitives, I should say. You could subdivide this after, probably get a bit of a weird result since we poly reduced this, but you know, again, it all depends on the camera. You know, from this kind of point of view, it will be fine. We get nice kind of bendy stuff. Let's do a flip book, but you know, since this takes so long, we'll get the same kind of general idea if we just flip book this. Okay, I'll just do this temporarily. Let me just tidy this up a bit. Delete that null. Press escape because it's trying to do that point deform. So let's visualize that. Move that. Oops, move these over and then just grab the collider. Let's do this. Okay, and then go into our camera. Let's move the camera around so the fracture is kind of happening in front of us. Yeah, maybe kind of like that. Let's zoom in closer. Cool. And then if we unpack it, maybe we can see those colors, help them stand out a bit, and maybe we can darken this. There we go. And then just do smooth shaded there. There we go. So the metal stands out a bit more. Okay, and then I'm going to zoom out and flip book that. Okay, got our flipbook here playing. So looks good so far. We got, you know, lots of small pieces. I like the kind of combination of some bits falling off and some like there. You see these big chunks kind of following along the previous simulation. So that's nice. We get that kind of combination, you know, a bit more dynamic that way. And obviously we get the metal bending as well, which in the render with the final, you know, remember this is just the proxy geometry. With the final geometry will look even better. And yeah, all nice. Looks good. Let's move on to the glass.